Hi guys. Um, this presentation is going to be about friction. We're starting to get into some problems where we'll add friction to it. It just kind of complicates it a little bit more as an additional force, but it's not that bad. So just so we know a little bit more about friction, contact force between two surfaces resists motion, always in the opposite direction of motion. So as an example, if you had a book on a table and you wanted to slide the book to the right, friction would be to the left. There are two types of friction, static and kinetic. Static just means the objects are at rest, they're not moving. They're resisting the motion though with static friction. And then kinetic is when the objects or surfaces are actually moving past each other. Um, Some books might refer to a third type of friction, rolling friction, but we'll later learn that rolling is just a type of either static or kinetic. Um, when objects like planes, rockets, and so on pass through the atmosphere, that's a type of kinetic friction because the surface that we're talking about would be the surface of the plane or the wing, and the air, sliding, the air particles sliding past that surface. A term used for that specifically would be drag. Now, what exactly causes friction? We have these micro welds, which are the small imperfections that every surface has. If you were to magnify any surface, you'd find that it's not completely smooth. A good example would be if you kind of look at your fingertips. You can see your fingerprint, the high and low points that create your fingerprint. Now, when these micro welds, these like high and low points on a surface, the better that they fit together, the more friction you'll have. Right. So think about how they lock together. If you look here, you see the high and low peaks and valleys fit together. That's causing friction. Now, a way to reduce friction would be to add a lubricant such as oil. And what that does is it just kind of fills those gaps. It fills the low points so that the peaks from the other surface can't really get in there. Now that the micro welds can't fit in to the other micro welds, the surfaces can slide past each other. As far as calculations are concerned, the formula for friction is mu times the normal force. Now, this is how we write the force friction. It's this cursive lowercase f, and then this symbol right here, mu, that's the coefficient for friction. That's a characteristic property of the materials that are in contact. For example, if you had a rubber tire on concrete, you would have a certain mu. If you had that same rubber tire on glass, it would have a different mu. If you have sandpaper on wood, it has a certain mu. If you had like a silk cloth on wood, you'd have a different mu. Okay, so it all depends on the two surfaces that are in contact. Now, for as far as the mu that you might be dealing with, you either have a static mu for when the surfaces are at rest, or a kinetic mu if the surfaces are sliding past each other. You already learned about the normal force. That's the contact force at 90 degrees between the two surfaces. Something else that I want to talk about, mu static is always greater than mu kinetic. So that means that the force of static friction will always be greater than kinetic friction. Now, why is this the case? If you think about the microwelds, when the surfaces are at rest, those microwelds, those peaks and valleys, can interlock more. When you start sliding or pushing one surface past the other, those microwelds come apart. And while the surfaces are moving, the microwelds never get a chance to kind of lock together again or lock together as much. So that's why static friction is always greater than kinetic friction. Now here's a quick example calculation. If you had a block of mass 10 kilograms at rest on a surface, the mu static between the surfaces would be given in this case as 0.250. There are no units for this coefficient. What's the force of friction between the block and the surface? So the force of static friction would be the mu static times the normal force. Now, when the block's at rest on a flat surface, the normal force is just equal to the weight of the block, or mass times gravity. So if we just take all these things and multiply them together, we end up with 24.5 newtons as the force of friction, and that's static friction. Okay, that's it for these slides on friction. There will be some more information to come, but this is a good starting point.